Hello, everyone, and thank you for attending today's webinar, OTN to Edge Building, Simplified Architecture for Premium Experience, sponsored by Huawei. Before we begin, I wanted to cover a few housekeeping items. In the middle of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you today, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the arrow help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green resource list widget. Towards the end of today's presentation, please complete the survey that is on the left-hand side of your screen. Your feedback is extremely helpful. Finally, an on-demand version of the webcast will be available about one day after the event and can be accessed using the same link that was sent to you earlier today. I'd now like to turn the event over to Analyst at Large at Heavy Reading, Simon Stanley. Simon?
Okay, thank you, and welcome from me as well. I'm very pleased to say that we've got some great speakers here for you today. First of all, we have Idroy Sibin, who is Transmission Senior Engineer at CTS. Next, we'll have a video from Yimin Lao, who is Manager and Transmission Senior Expert of Delivery Center at China Unicom Guangdong. And then finally, we have Claudio Lugari, who is Transport Network Solutions Director from Huawei. We'll start today's presentation with a short introduction from me, and then I'll hand over to Idroy from CTS, who is going to be talking about building all-optical network for all services. Next, we'll have a video presentation from Yimin at China Unicom, who is unable to join us today. And we'll finish with a few slides on Edge OTN from Claudio at Huawei. At the end, there'll be a Q&A session, so please do send in any questions you have for Idroy and Claudio as we go through. Who is unable to join us today. Now, in this webinar, we are discussing edge networks that are the key to delivering the enhanced services that individuals and businesses require. Many businesses and government organizations have moved to cloud storage, both public and private. In place of private networks, most enterprises are moving to virtual private networks, covering campus networks, multiple business locations connected through premium private lines, and also remote locations, including branch offices and employees working from home. And obviously, over the last 15 months or so, video conferencing has really become a vital tool for many businesses and individuals. High definition and ultra high definition video is widely accessed by households across the world. Cloud gaming has a dedicated following, with users keen to ensure their network service does not leave them at a disadvantage to their opponents. Cloud-based augmented reality and virtual reality solutions promise enhanced gaming experiences and have seen much investment over the past few years. And then social media such as Facebook and YouTube also rely heavily on that video. And in fact, video is widely accessed through mobile devices and represents more than 70% of wireless data traffic. Cloud gaming and cloud AR/VR are growing applications as 5G networks deliver enhanced user experiences. The combination of high bandwidth and low latency services, together with high definition video and cloud AR/VR, will enable enhanced stadium experiences with immediate playback and analysis for spectators in the crowd. Connected vehicles are rolling out across the world, and with most manufacturers linking up with wireless service providers and system developers. More widely, the Internet of Things is expanding rapidly with ever more connected devices. In addition to smart devices in the home, this really sort of brings us back to the enterprise, with connected devices across many industries, from vineyards to mega factories. Smart manufacturing and developments for Industry 4.0 require cloud-based services and connectivity. Beyond manufacturing, remote monitoring and surveillance of devices, sites and equipment can deliver significant cost savings and enhanced business operation. Now, these enhanced services require differentiated network capabilities. High definition and ultra high definition video require high bandwidth. Cloud gaming requires low latency connectivity, but not high bandwidth unless the actual game content itself is being downloaded in real time. Remote monitoring and surveillance requires a high availability network in case critical events are missed. The rapidly growing number of connected IoT devices require massive machine connectivity and need to work with remote systems that require battery lifetimes of 10 years or more. Towards the center of the chart are a whole range of services that require a mix of network capabilities. Cloud AR, VR, and Stadia experiences require both high bandwidth and low latency. Video conferencing also requires reasonably high bandwidth and low latency. Cloud storage needs to be accessed quickly and must be available at all times, unless there's a local caching of critical data. Smart manufacturing requires low latency and massive connectivity, but also manufacturing systems need to be connected at all times to ensure maximum productivity. Connected vehicles and infrastructure require low latency and massive machine connectivity, but also have to be designed to work safely when that connectivity is lost. At the center are virtual private networks. These networks need to provide high bandwidth for HD video and cloud storage, low latency for cloud AR, VR, and video conferencing, and then massive machine connectivity for that smart manufacturing, and also high availability to ensure 24/7 operation for the organization. The access network really provides the key link between the customer premise equipment and the telco core network. The virtualization and disaggregation of networks has created many clouds. Edge clouds are connected back to telco cloud data centers run by communication service providers and onto the public clouds operated by companies such as Alibaba, Baidu, Tencent, Amazon, Facebook, Google, and Microsoft. The radio access network with support for 5G is increasingly being virtualized with separate functions for the radio unit, distributed unit, and centralized unit. Many of the front haul, mid haul, and back haul connections are being supported by PON or other fiber-based technologies. An increasing percentage of business and residential broadband connections are being directly supported by PON, delivering fiber services to the home or business premise. Each of these clouds have different network requirements based on the services being supported, and a higher fiber penetration is expected, particularly for wireline connections and 5G transport. Both PON and OTN are optical networks that are relatively mature technologies. PON is a shared fiber connection for fiber to the home and fiber to the premise, and is widely deployed for home and small and medium-sized enterprise broadband. PON is a scalable solution with most current deployments supporting GPON and growing deployments of 10G PON. The next generation will be 25G or more likely 50G PON. All these solutions can use the same fiber infrastructure, typically with 16 or 32 connections per fiber. PON connections can be symmetric or asymmetric depending on the application. Going now to the right, on OTN is a good kind of transport for different kinds of services such as SDH, Ethernet, and 5G transport. OTN is widely used in backbone transmission networks due to its efficient DWDM transport capability. OTN provides guaranteed bandwidth with no congestion, zero packet loss, and deterministic latency. OTN supports fast service restoration and scales to N times 100 gigabits per second. Over the last few years, there's been significant industry efforts to extend OTN to the edge to replace TDN networks with small granularity OTN solutions. OTN deployments continue to grow in every region, as shown in this chart, which I've taken from the latest Omdia optical network forecast issued at the end of last year. Global OTN equipment sales are expected to continue in the 5 years to 2025. And by 2025, Asia and Oceania will represent 62% of this market, and EMEA 22%. The total PON equipment market is also forecast to grow significantly through 2025. China remains strong, but diminishes as a percentage of the global market. EMEA is forecast to grow from $1 billion in revenues, $1 billion in revenue, in 2018 to $3.4 billion in 2026. And strong growth is forecasted for selected countries in Western Europe and Africa. North America is forecast to grow from $689 million in revenues in 2018 to $1.5 billion in 2026. So hopefully that's given you a good introduction to the topics that we're going to be discussing through this webinar. And at this point, I'd like to hand over to Idroy from CTS. So over to you, Idroy.
Thank you. Hello, ladies and gentlemen. I'm Idroy Sibin from Celcom Timur, Sabah, Sdn Bhd, Malaysia. Next, I would like to share the case of building all optical networks for all services of CTS. Okay, CTS is the largest network bandwidth for Malaysia's telecom operators vendors in the state of Sabah, also providing comprehensive services in multiple fields, including 5G, FTTH, and enterprise private lines. Our transmission network is 100% fiber optics network, and we have the widest fiber optics network in the state of Sabah and Labuan. Besides the fiber resources, the network has been equipped with the latest technology, both in hardware and software, serving consumers, enterprises, and wholesales. Next, CTS has the all-optical network strategy and built the DWDM backbone network and MSTP in aggregation and access layers in year 2009 to meet our customer service requirements. However, there are more and more challenges in the current networks, especially in aggregation and access layers, along with the rapid bandwidth demand from operators and the strict network requirement of new services like 4K or 8K videos, enterprise private lines, and etc. For instance, in the backbone layer, the link utilization is more than 75%, and there is not sufficient capacity for future growth. And then next, high OPEX caused by high equipment footprints and high power consumptions. And then next will be low operation and maintenance efficiency. For instance, lack of network self-healing capabilities, leading to frequent service interruption caused by fiber cut. And last one will be more and more new services pose high requirement on the network, less latency, zero packet loss, low jitter, and etc. In order to address these challenges, CTS decided to evolve current optical network to all optical network, meaningful MS OTN networks since 2020. With this target network, the OTN will be extended to the aggregation and access nodes, building a flattened and single hop network. It will bring much lower latency for 5G services and improve the operations and maintenance efficiency. Here we can have a clear picture of CTS, all optical network, which is used as a digital infrastructure for all services. This network can bring us following benefits. First, ultra large capacity. We have upgraded from 100 gig per lambda system to 200 gig per lambda system, doubling the capacity in the backbone smoothly. 200 gig solution was also introduced in the aggregation layer. And then the second one will be ultra low latency. Thanks to the all optical networking, we are able to realize one hop connections without frequent optic electrical conversions. It will reduce the latency significantly and ensure committed millisecond latency. And then the third one will be high availability. thanks to the add-on technologies, up to 99.99% service availability can be realized to cope with the frequent fiber cut. And then the last one will be intelligent operations and maintenance with OVPN, embedded OTDR functions and optical power monitoring. Proactively, operations and maintenance can be achieved. Okay, next, I would like to talk about the advanced technology used in the network to reduce site TCO and enable easy operation and maintenance. First is the MS-OTN solutions. MS-OTN capable equipment has been widely deployed in the network to simplify the sites. MS-OTN solutions can integrate 6 types of services, including SDH, PDH, packet, OTN, ponder, optical into one box and construct one network for all the services. Second is the implement add-on to improve the service availability. And the third one is the built-in or TDR functions, for instance, to realize tester-free for fiber quality management, measurements, OSNR monitoring and detections. Okay, besides all these technologies mentioned, the key to realize the all-optical network is the OTN to edge, meaning OTN to aggregations and access nodes. With the OTN to edge, this network can work as full service transport like 2B, 2H, and 2C. Thanks to the hard isolations advantage, it can bring guaranteed high quality experience like low latency to all kinds of services with the one-hop connection. The MS-OTN equipment deployed in our network are highly integrated with low power consumptions, and they can be installed both in indoor or outdoor scenarios. For instance, in the aggregation nodes, the 5U boxes were installed in outdoor cabinet where there is limited space. With OTN to edge, it can enlighten the fiber, boost the fiber capacity greatly. It is quite obviously to see that with 200 gigs ready systems, it can bring up to 80 times 200 gig capacity, will meet decades evolutions. In addition, with a lot of built-in functions in the OTN system and management systems, it can manage all the fiber effectively. Well, that's all my sharing today. Thanks a lot for your time.
Okay, thank you, Idroy. And we're now going to go to our short video presentation from Yimin Liu at China Unicom Guangdong. So that should start just now.
Hello, everyone. I am Luo Yiming from China Unicom Guangdong. It is my great pleasure to share with you the practice and the development of China Unicom Guangdong's all-optical network. China Unicom has implemented the development strategy of 5 new and 5 high to accelerate enterprise digital transformation. Currently, China's digital applications are divided into 3 categories. The first is the digital home personal applications, which focus on the mobile payments and the social interaction. China Unicom has provided 230 million optical ports to provide high-quality broadband for thousands of households. Second, digital industry application mainly focuses on the online education and telemedicine. Currently, China Unicom has covered 80,000 buildings nationwide. Third is the digital government application. Currently, China Unicom's government and enterprise quality network has achieved OTN coverage in more than 300 cities in China. China Unicom Guangdong is committed to promoting both network and service improvement strategy, continuously involving quality network and improving capabilities, rapidly deploying networks around the service and supporting high-speed business development. However, in the development of future-oriented large granularity, low latency, intelligence, agile, and cloud network integration services, the barrier network face the following challenges. First is the network capability is insufficient. The access capacity of the MSTP network is lower than gigabit. However, a lot of VIP customers require 10 gigabits, even up to 100 gigabit or higher. Second, the network structure is complex. The chimney structure, many layers, and the transmission efficiency is quite low. The third is the network is not intelligent enough to automatically provision service for end-to-end circuits. The last one is that the network doesn't match the operation mechanism, which affects productization and integrated support of the network. In the previous transition network construction mode, 21 local networks needs to be constructed in the 21 cities in Guangdong province, and the 21 dedicated maintenance team needs to be deployed across city services are scheduled by segments. The service provisioning process is complex and it takes a long time. China Unicom Guangdong broke the traditional hierarchical convergency thinking and introduced the world-leading technologies. A flight mesh-based all-optical network covering more than 800 aggregation nodes has been built for the network of 21 cities in the province. The network uses SDN controller, ROADM, and ASON technologies. This enables intelligent service scaling and unified management and control on the entire network, which effectively supports the rapid development of subsequent services. Based on the provincial integrated all-optical base, China Unicom Guangdong has built an SD-OTN high-quality enterprise network to provide high-quality OTN private lines for various industries. The SD-OTN top-quality enterprise network has 4 features. First, network integration, one network, unified planning, construction, and operation and maintenance. Second, wide network coverage. It covered 844 optical nodes and processing coverage at its access layer has been achieved. Third, all-optical networking. There are 4 OXC sites, 267 ROADM sites, and more than 1,000 OTN CPEs. Fourth, intelligent network. NCE interconnect with the production system to implement quick provisioning, self-service, and intelligent operation and maintenance of private lines. In addition, we provide processing coverage at the access layer for high-value areas. For example, in one city, to support the bandwidth acceleration for the private line networking at a bank branch, up to 150 optical nodes are deployed at the access site to achieve deep coverage and fast service access. Based on our leading network advantages with the effort of our business department and the capability of SD-OTN network, we realized the revenue of the year when the network was built and put into production, which far exceeded our expectations. In addition, our high-quality all-optical network meets the expectations of various industries for high-quality bandwidth. During this period, we implement projects in related industries, such as banking, securities, government, large enterprises, education, and IDC center. In less than 1 year, our SD-OTN network achieved a contract amount of over 100 million Chinese yuan. In addition, the investment of a high-value customer is reduced by 30 million Chinese yuan. In the future, we have following considerations for the development of our optical networks. First, we will continue to refine the basic network, fully release the basic network capability of the SD-OTN, and realize SDH modernization. Integrate multiple network to remove the old device from the network, cut over SDH services to the SD-OTN network, and exit the network in an orderly manner to fully utilize network-wide resources, such as optical cable, office buildings, and power equipment. Second, continue to consolidate the SD-OTN network and proactively deploy integrated access points in front of the network. Finally, enhance the modem network to build a network with the optimal delay. At present, we have carried out a pilot project in Huizhou, Unicom, and achieved remarkable results. For example, the network coverage increased from 19 segments to 38 segments. In this way, the number of the service interruptions decreased by 33%. Second, reduced up to 519 pairs of backbone fiber core per kilometer, and 880 pairs of fiber core per kilometer were revitalized. Third is removed up to 17 OTN devices, 4 brass, 13 EPON devices, and up to 200 MSTP devices. Finally, is the electricity fee is reduced by 500,000 Chinese yuan, and maintenance cost has been reduced by 170,000 Chinese yuan every year. In the future, we will promote it in the whole province and expand OTN coverage and realize SDH modernization. The second consideration for the development of all-optical network is to continue to optimize the service network, implement optimal user experience in the cloud, and provides the ubiquitous access to 2 kilometers down to further build an all-optical network. It includes the following 3 parts. First, high-value industry private cloud, such as e-government cloud, financial cloud, and medical cloud, work with high-quality optical network to achieve cloud network integration. Second, use the thermal analyze method to deploy all-optical anchor in front to identify key areas and buildings. We plan to deploy more than 6,000 optical anchor in front to build a 2-kilometer ubiquitous access circle and shorten the provisioning time of lead line services. Third, establish a prosperous ecosystem, especially for commercial buildings. We can use PON plus OTN convergence and passive access and wide coverage advantages of PON to make OTN private line ubiquitous and serve more and more small and medium-sized enterprises. This year, it is planned to cover 100 buildings in this kind of innovation pilot. That's all for my sharing today. Thank you very much.
So thanks to Yimin Yao from China Unicom Guangdong for that short presentation. And I'm now going to hand over to Claudio Lugari from Huawei, who will be talking about a development that brings together fixed access using PON and also OTN. So Claudio.
Hi everyone, my name is Claudio Lugari. I'm Transport Network Solution Director in Huawei. I will talk, as Simon was mentioning, about Edge OTN building all-optical network architecture. So let me start highlighting a very important point from our point of view that Simon already highlighted, but let's say that we are seeing a scenario where the services are moving from being best effort to best quality or even premium quality. And I would say that the COVID crisis even highlighted this more because we had a lot of online education for our children, conferencing for work. So working at home is nice, but it leads a lot of connectivity. And thinking about enterprises, this is even more true. So the fact that enterprises are moving into the cloud, and if we think about financial or governmental institutions, this leads to have by the point of view of services, zero buffering, zero drop services, no packet loss, no interruptions, very high reliability. Droy was mentioning at least 4 nines, going toward the 5 nines, and very low latency from the edge to the core. This poses very stringent requirements on the network. So it's very important to have guaranteed bandwidth on the transport network, low packet loss ratio, very low latency, and high reliability. And this is ideally in order to connect the edge to the core, in order to keep these key performance parameters under control. Now, to provide this scenario, we see some challenges looking at the historical deployment of the access or the edge and confirmed by the operators we are serving around the world, we see that there is a challenge in terms of limited space and high power consumption. This is fully confirmed. The point is also the fact that head dissipation is even complicating more the scenario of the high power consumption. So it's very difficult to install the different equipment on the edge. We need to consider the space and the power consumption, which is, first of all, a physical issue and then a cost issue. Then, considering how the networks have been deployed up to now, there are a lot of siloed networks for different applications. Home broadband, mobile broadband, campus networks, enterprise applications, private lines. And these siloed networks means massive equipment. In the past, this was faced at some extent, but not fully. So this kind of stacking is still there. And the last point is that the network is congested. So we saw in the past years a big boost on the traffic requirement due to the video, but it was also very difficult to upgrade the nodes and to upgrade the networks when the traffic was required on specific sites and specific links. So a very complex scenario in terms of upgrading when the hotspots are burdened by traffic or new requirements, very difficult maintenance. So how to improve the network efficiency of both sides and the network? We think that all-optical network architecture enables premium experience for the services, clearly. And what does it mean, all-optical network architecture? The first point I want to highlight is the one-hop or frog-hop architecture. So moving the actual network from installing a fixed optical add-drop multiplexer or even reconfigurable optical add-drop multiplexer and moving to end-to-end optical cross-connect, meaning, let's say, using equipment with a full optical backplane. I will highlight this again, but the point is that this will add a lot of flexibility to the optical layer in terms of connectivity and will help taking control some challenges like the key performance indicator of the latency. The other technology that we see fundamental is the penetration of the OTN up to the edge. And obviously OTN, as Simon was saying, it's a very successful technology, very robust, deterministic, transparent, but it has some limits like the granularity. So we are working in order to improve the granularity of the OTN through liquid OTN, which is Huawei naming, and 1 gigabit connectivity, thanks to the new containers that are under discussion in the ITU-T standards, the optical service unit. Last but not least, the co-location of OTN with OLTs, with the site that we called Optics Super Site, in order to provide point-to-point or point-to-multipoint connectivity for large enterprises, but also for small, medium enterprises that may have different requirements compared to large enterprises. Let me also highlight that the one-hop or frog-hop architecture that we foresee, so the collapse of the multiple stacking networks and siloed networks will grant more capacity and upgrade on demand of the traffic required. And furthermore, will help to control the performance indicators, the access nodes, and the aggregation nodes. And OTN and WDM are ideal technologies for that. Beyond that, we have seen different studies highlighting that the total cost of ownership bound to the op-by-op elaboration of the signals, as it is done in many networks in these days, has an explosion in terms of cost beyond a certain amount of traffic over the rings. Here is just an example on the right side, highlighting, let's say, a ring of 6 nodes, and beyond 30 gigabit, the TCO explodes. The exact numbers may differ from different operators, but not the overall conclusion. So the point is that with the one-hop connectivity, so using WDM or audio containers, you can contain definitely the TCO and arriving to squeeze it up to 50%. Then again, let me highlight that the simplification of the optical layer is fundamental to us, and this definitely starts with the end-to-end optical cross-connect, which can simplify the optical layer, saving fiber, space, and power consumption. This started in the backbone. We provided the OSN 9800 P32 first, and then the P32C compact, deploying technologies like the fiber circuit printing in order to squeeze 1,000 fibers into an A4 sheet size, and then improving liquid crystal on silicon technologies to add more resolution in order to cope with the higher spectrum required and the higher bit rate associated with the single wavelength. Then we think that also in aggregation sites and in the central offices and sub-central offices sites, it's very important to provide this kind of flexibility. And we have then developed a solution which is called OXC Lite solution, so squeezing different functionalities like the wavelength lattice switches, optical time domain reflectometer, optical amplifiers and connectors into one board. So just one board in order to manage WDM direction in a possibly meshed ring or mesh network. Last but not least, again, we are fully aware that automation is important in order to contain the cost associated to the maintenance. So with integrating probe and sensor in order to monitor fiber connectivity, and so one click to connect the fiber, and in loop commissioning algorithms, we were able to squeeze the commissioning timing associated to the optical network from hours to minutes, the site installation, obviously. Why do we think that HODN is an innovation? Because it can accelerate the fixed mobile enterprise convergence development, so highlighting how much importance we see into the enterprise space. So we think that HODN can cope with the challenges I highlighted in the beginning, so limited the room space, insufficient power supply, and shortage of fiber. HODN can be co-deployed with OLTs and BBUs, providing a convergent network and giving the possibility to connect in one hop to the cloud or to the core of the network. So very small footprint, a lot of, let's say, technologies in order to allow a squeeze of the time to market for the new services, one box in one site, and a full service access. So the characteristics that we associate to the Edge OTN are definitely a flexible deployment, a very high opto-electrical integration, which is provided by the so-called X+Y OTN architecture, and a smooth evolution considering what is deployed in field, a lot of SDH and IP rings that usually are gray rings still, and maybe upgraded to OTN and WDM. Let me highlight the fact that at both aggregation and access nodes, the Edge OTN solution uses equipment that can be installed outdoor and indoor. Thanks to this equipment, which are very compact, 5 use for the aggregation nodes, 2 use for the access nodes, we can save up to 50% of the space, and thanks to patented heat dissipation technologies, we can really squeeze the heat dissipation by 200%. In an indoor deployment, we can have up to more than 160 200 gigabit ports, and all these equipment are definitely IP55 dustproof and waterproof, because we know that they work in very obviously outdoors, talking about the outdoor conditions, in very tough conditions. And that's why we invested a lot in order to maintain stable operations in high temperature environment. In the access nodes, we can definitely deploy indoor and outdoor, and the installation can be floor mounted. We can have wall mounted, pole mounted, and in the case of even the pole mounted solution, we can co-install with OLT for a total space of 3 use, and in a cabinet which is taking 5 use. Very easy to install. And we also pushed a lot the concept of providing protection and reliability against corrosions, more than 100 professional tests to, let's say, improve the resiliency of these kind of nodes and improve the batteries in order to provide long backup power. Then here I enter into the so-called X plus Y architecture. I mentioned how much we think it's important to have architecture, or better, the optical cross-connect extended overall the network, but we know that there are challenges in terms of the cost for the edge, and the access. So we have squeezed also the FOADM solutions into one board. Here for the edge OTN, we have 4 wavelengths at drop-in case provided by one board, which can cope with one direction, and in the aggregation nodes up to 40 wavelengths. The X plus Y solution is the fact that we have backplane connectivity, that's the X, and the Y solution for the max ponders is the fact that the max ponders are connected to the line, to the client ports, and to the backplane. And these can provide the possibility to feed the wavelengths also through extended client ports. Again, this is done in order to reduce the space, the power consumption, and in order to fill more efficiently the wavelength associated with the solution. We have also integrated, and we are integrating with a further line size like the 25 gigabit through SFP28 and 50 gigabit through QSFP28 in order to take into account the latest standardization in March 2020 provided by ITU-T G709.4. So we may have an upgrade step from 10 gigabit, not going straight to 100 gigabit or 200 gigabit, but providing 25 gigabit and 50 gigabit. And this will squeeze the cost per bit associated to the solution of 50% with the 25 gigabit and further 40% with the 50 gigabit. Here an example on how to deploy and how to provide the smooth evolution for the service growth with Edge OTN. So you have, as I was mentioning, there are IP or SDH gray rings transmitting over O-band, which is the first window utilized in the optical transmission, and in general gray light. So we can add a photonic layer through the Edge OTN, and then at the second step, adding max ponders for 100 gigabit or 200 gigabit wavelengths. And on the client rates, we have 10 gigabit 25, protecting the line side through traditional optical protection, and adding at a third step extended tributaries in order to fill with lower tributaries like 10 gigabit or gigabit Ethernet and fast Ethernet, granting 100% line bandwidth utilization and without the cost associated to the OTN switching central switch, because this is provided, the connectivity in between the Y ponders and the extended tributaries are provided through the backplane. This is just an example on how this solution can evolve the existing rings without disrupting them and giving the possibility to dismiss them after some time, having expanded already the capacity and provided the one-op architecture. This is a case we already heard from let's say our colleagues some application of the technologies I was mentioning. This is a case where we provided a converged network, and let me mention mobile broadband, fixed broadband, and the business to business, so the private lines for the enterprises, which are fundamental in our vision of the evolution of the transport network, because these are really premium services, and through OTN, we can not just provide the key performance indicators required by this space, but also differentiate them according to different solutions. One important point here, the connectivity from the access to the core is provided either through wavelengths, either through ODU containers, and the OTN gateways. Last slide from my side. Definitely, this is another point I want to highlight for you, the optics supersite. So the co-location of Edge OTN with the OLTs, and so providing over the OLT an uplink through 10 gigabit OTN. And why we think this is a very efficient solution, because through Edge OTN, we can, let's say, provide multiple access, not just for the VIP enterprises, which may be connected through CPEs plug and play, VIP enterprises, I mean governmental institutions, financial institutions, large enterprises, which are ready to pay more for, let's say, a granted connectivity and very high level of KPIs. Maybe there's more medium enterprises are not ready to pay as much, but they may enjoy the existing PON networks and with the connectivity from the OLT to the edge OTN, starting from the OTN uplink, they may have, let's say, all the advantages of the OTN granted connectivity and go straight to the cloud. So granting an ultra low latency, a fast time to market for the new services, and what we call the super uplink, and even enjoying, let's say, the improvement that we have associated to the OTN technologies thanks to liquid OTN. And that's it. Thank you for listening, and I will land back to Simon.
Okay, thanks, Claudio. From Huawei, I think there was a question about which vendor was speaking, so hopefully you now have that information. And that brings us to the end of our formal presentation. So we're now going to go to our Q&A session, and we have Idroy and Claudio on the line to answer your questions. We've had some good questions come in already, but please send in any more that you have, and we'll get to as many of them as we can. Our first question is, what are the challenges to deploy OTN to the edge, and how are you solving them?
Hi. Well, this is a very good question. Thanks a lot for asking this. Well, all-optical network is a CTS network strategy, and the key is to deploy OTN to aggregations and to the access sites. One of the challenges is insufficient room space for the equipment in some aggregation sites. That's why we choose MS OTN solutions. It is a multi-service platform with OTN technology, one box for all service access and optical electric convergence. It means that one box for one site to simplify the site. Secondly, we adopt outdoor cabinet solution for some aggregation site and plan to use even smaller outdoor cabinet, which can be mounted on the pole or wall for access sites. Thank you.
So I go back now to Claudio for this next question. So the question is, what is the key technology to make Edge OTN so compact and easy for flexible deployment?
Yes. The key technologies by which, first of all, the Edge OTN has been taught in order to cope with the challenges I was describing at the beginning. So we knew that it's fundamental to provide a convergent transport network solution, and we are burdened by requests in order to provide, let's say, solutions that may grant a very high transport network requirement and key performance indicators. So you were mentioning, and I was mentioning, the bandwidth, which is still a challenge. It will always be a challenge, and it's fundamental to address the bandwidth issue. But then it will be also the latency, the availability, and the jitter in some cases, and so point about deploying OTN instead of packet solutions, so circuit solution instead of packet solutions. About the technologies that we have taken into account into Edge OTN, I would say that the first point to highlight is the optoelectrical integration. So we are doing a huge effort in order to squeeze any solution we are providing into single boards without losing reliability, because this is also the other very important challenge. If we will compact everything, we may raise the risk of, let's say, harming the reliability, and we cannot, exactly because we are thinking about best quality services or even premium services. So optoelectrical integration, the squeeze into line pluggables like 200 gigabit into CFP2s over 50 gigahertz, so very high line rates, even at the access in order to avoid any issue starting from the access. I was listening to other providers, even North American providers, saying how much challenging was the deployment of the latest Fortnite, let's say, versions, or the launch of new video services. And this is more or less happening all over the world. So the edge is starting to be like a block point for the services. So we need to provide solution that can be installed in field, very reliable. So other very important point is the stable operation at high temperatures and against the environmental tough conditions, like the fact that we have done so many tests in order to avoid any trouble to the services, even in outdoor conditions.
Okay, and Claudia, I think I'll stay with you for this next question. So the question is, for the OptiX SuperSite, what are the innovations to ensure the high quality experience of OTN P2MP private line services to SMEs?
Okay, so again, we have tried to provide a smooth upgrade path in terms of knowing that there are PON networks out there, and how to improve the solution provided to the small, medium enterprises. Let's not forget that we invested a lot into OTN, and we think that OTN is ideal solution in order to provide these premium services and best quality services. This thanks to the fact that OTN is very robust and deterministic technique, but the fact that OTN, as you were highlighting, has been installed across the world for the last 20 years or more. So we think that improving OTN, we will improve the quality of the services. So that's why we thought that co-installing OTN and providing to the OLTs an uplink through OTN will be a great step ahead, and then having the possibility to connect straight the OLT up to the core. The other point is at the upper layer, in order to provide end-to-end connectivity for the services, there is also to mention the SDN architecture, software-defined networking. So we have developed an SDN architecture according to ACTN architecture in IETF, and so we have different domain controllers. It is possible to integrate the different domain controllers in order to provide end-to-end connectivity. Another very useful technology in order to extend the management is the CPE dual wavelength that we will install in field, and it will provide, let's say, the connectivity for the bandwidth and the extension for the management over the other wavelength.
Okay, well, there's another question here. It says, as you mentioned, edge networks are key to delivering enhanced services. How can OTN solution help the enhance the capabilities of edge networks to do so? Now clearly, I was talking earlier on about how the different services needed to be provided in the world we're living in today. And obviously OTN provides a lot of those capabilities in terms of its high quality experience and guaranteed bandwidths, as I was saying. I'm just wondering, Claudio, what do you see as the other capabilities that OTN is bringing here?
Well, I think, as I was mentioning, the fact that we are investing in liquid OTN, I think it's a great improvement of the possibilities of OTN itself. It's not just the fact that we are going with more granular bandwidth, and that's again a great step ahead. But for example, we are improving the encapsulation of the OTN and then also the latency associated with the technology. And the other point is that the granularity issue is also a cost issue. So, for example, small medium enterprises may not be ready to pay for a gigabit connectivity, it depends. There are a lot of different scenarios across the world. So for some, it may be strange that they are not ready to cope with the gigabit Ethernet connectivity, for others not. Providing this kind of granularity, so up to 2 megabit, and extending the number of hard slices that we are providing over the 100 gigabit or 200 gigabit connectivity starting from the edge, we think we really improve the scenario in terms of control of the services and in terms of providing best quality service. That's really the heart of our vision in extending these kind of solutions up to the edge.
Okay, and then I think we've got perhaps time for one more question. So in terms of combining OTN and PON technologies in the way that you've been describing, I mean, clearly that provides some great solutions for private lines in terms of providing a solution for people who are perhaps a bit more cost sensitive in terms of their solutions. But in terms of operators, what do you see as the big benefits in bringing together OTN and PON in the way that you've been describing?
Well, I would say enlarging the range of a new solution and very effective in terms of, let's say, KPI as it is for OTN. So circuit elaboration, providing hard slices for even for customers that are not used to this kind of solutions and may benefit as it has done, for example, by financial market or governmental market or even large enterprises up to now. So, and the customer churn is really a burden right now. So it's really important not to lose customers and providing them an upper layer of quality through OTN technology. We think it's the best way in order to attract new customer, even in the small, medium enterprise range.
Okay, great. Well, I think we've probably just about run out of time for this session today. So thank you very much for attending the presentation, OTN to Edge, Building Simplified Architecture for a Premium Experience. And that's brought to you by Light Reading and Huawei. And on behalf of our speakers today, Claudio Lugari and Idroy Sibin, and also Yimin Liu, who gave the video presentation, thank you very much for listening and have a great day.
Thank you and hi everyone.